that I'm late. I normally try as much as possible to cut my class late, but there are instances where there's generally a series of questions from students, and so yeah. Um, Kindly asking if maybe somebody can confirm if you can hear me just fine. I know you can see my screen, but just need confirmation if you can hear me.
Yes, we can hear you.
All right. So thanks a lot. We're going to continue our discussion. We are wanting to wrap up our our discussion of the current module. I want to call it a module really because you'd have noticed that we've covered quite a bit in this interaction, a lot actually. Thankfully enough, we are about to get to the end, I guess, if I can call it that. Um, so when we met last, by the way, before I start, I think I got a comment. I saw a comment on the Google Classroom, right? I don't know if I can't remember who that was. I don't know if it's. I have to check here, but there was a question on one of the materials that I have uploaded. I don't know if you can check this on the stream itself. So there's a comment on the code examples that I provided, is it? I'm not sure if Miss Longwani was able to follow through with the instructions. So I was trying to find out, ideally, how to use these code examples, right? So you notice that what I've been doing is whenever there are practical examples, I'm sharing these. These are links to Google Colab files, ideally, right? So the idea is when you have access to this document, what you must do is, this is an IPython notebook, is it? So when you click on this hyperlink, it will take you to, obviously, Google. So Google Drive by default, right, will probably, in your case, it will likely not know what sort of application it should open this .ipynb file. IPynb is just short for interactive Python notebook, is it? I interactive py Python NB is notebook, ideally. In my case, I've opened a series of files like this before, so this thing knows that I can open it with Google Collaboratory. But the idea behind these files is you can download them, is it? So when you download this thing, I'm going to download this. It's going to be presented on your local file. I mean, it's going to be downloaded onto your file system, your local file system, right? Like this. And if you remember our discussion of how we access these notebooks, what I can do then is I can say, well, I want to open this thing on my local machine. Is it? I'm using environments myself, so I'm just going to activate my environment. Source. I'm going to activate the environment for this course, and in essence, I'm just going to move this file that I've downloaded, is it? I'm going to move it to this directory again, okay? So I will go to this directory, and then I'm going to say I want to get this file that I've downloaded from Google Classroom, and I just want to move it in here, the folder that I'm working with. And from here, I can run what? Jupyter Lab, right? If I wish to. I'm going to run Jupyter Lab, but what Jupyter Lab is going to do is it's going to open this web application. If you remember our discussion, we said what Jupyter Lab does really is, what Jupyter Lab does, it creates a web application for you, right? So it's going to open this on port 8888, yeah, localhost. Automatically, this thing will be opened in your browser like so. Notice on top here, localhost 8888/lab ideally. So once this thing is spawned like this, what I can then do is, by default, it's opening notebooks that already have it. What I can then do is I can navigate away from code here and go to the folder which has this file, you see, that I've downloaded this, and then I'll be able to open it like so. So in essence, these files are these are interactive Python notebook files. So you can only open them using those applications that we discussed, right? Jupyter Lab, Jupyter Notebook, and Google Colab. So my comment was simply saying what you can do is, if you want, you can download them and then re-upload them, right? So the way I've downloaded them, I then go to colab.research.google.com. I just go to colab.research.google.com. And then from here, I can then, instead of creating a new notebook, because I've already downloaded that notebook, I'll navigate to, see this panel to the left here, examples, recent, Google Drive. I'll go to upload. And then from upload, I'll browse my machine, my local machine. This file is in downloads. And the file I've downloaded is where is it? I've moved it again. I cut and pasted it somewhere. So it's in projects, work, 2026, this 7-foot-1 folder, and it's here. And then I can then open this. So once I do this, this thing is going to open this notebook right within Colab. So this is ideally how you would use this. You can either download them, re-upload them to Google Colab, and then you can play back these notebooks and look at the examples ideally, if you notice. The other option is, I don't know if all of you can see this, but from Google Classroom, because this is Google Classroom, yeah? When I navigate to the part that has notebooks, I will open this notebook like this. By the way, Classroom says it's unknown because it doesn't know the format, right? It knows that this is a CSV file. It doesn't know that this is an interactive Python notebook idea. From here, right at the bottom, but where is it? Once this finishes loading, you notice here, no preview allowed. I can download or I can connect more apps or something, but it knows, my Google Drive knows that I can open this either with the text edit application that I have or Google Collaboratory, right? So I can click this ideally and be able to open it. This is like a one-click access to the notebook itself without downloading it first to the computer and then re-uploading it to Google Colab or something like that. So hopefully this kind of answers the question associated with this. And in the event that a number of people are experiencing difficulties on how to access this, there you go. Something else worth mentioning is that I deliberately, and I think this is for not the examples, but the lab. For the lab, I don't know if this is the one. This is the one. For the lab, what I've done is I've made reference to a file, the CSV file itself. So you notice in the labs that if you read through these instructions, right, there's this here. It's right up here where you're being told that you want to make sure that you download the CSV and it should be in the same directory as the notebook. Okay, so for this, because there are two notebooks, right? There's the one with examples that I'm using in the module we're covering right now. And then there's another notebook, which is essentially like a lab, is it? Practice questions, if you will. I think I do also provide like answers to all of these things here. But so for this to work, you must also download this file here, this CSV file. Once you download this CSV file, it must be saved in the same location as this notebook. If you're running it on Colab, you better make sure that you open this panel, right? And then you upload into your session. Because observe, if I attempt to run this right now, it will fail, I guess, I don't know. If I run this, when I get to a stage where after step 1 here, if I run this code cell here where I'm importing CSV and stuff, if I run here, right, it's going to tell me file not found. Why is that? Because this file is not in the same location as this notebook. For this to be in the same location, what I must do is I must go to Google Classroom and I must download this CSV file. So just click on it, and then and then you click on, where is the download file here? I want to download this thing. This is a problem here. I want to. This is horrible stuff. Okay, maybe I can open it in a new tab and it will download or something. It's going to be the same thing, I guess. So I click on it, then I view details, and then I can download it. There we go, right? So I'll download it. Once I download this file, right, it's downloaded, I can then go to Colab. You notice I have an error here. And then I will upload here, upload session storage. I'll go into my downloads folder, choose this CSV file, open. Once it's uploaded, Google Colab will know that the file that I've uploaded is the same location as this notebook. So through to that, if I run this now, this will be able to work. You notice this has worked without an error. Okay, so hopefully this is making sense. I don't know if there are any questions about this or the exercises or something. Okay. Okay. Then we're going to proceed, I guess. I hope. Yeah, there we go. Okay, we're going to proceed then, if that's the case, and we're going to transition to our discussion of these comprehensions, is it? Okay. Hopefully we've had fun looking at the different data structures and the examples here. So just to get everything started here, what's called a list comprehension is a very simplistic way or concise way of creating a new list by applying an expression to each element or item in the existing sequence, ideally. Okay? And you soon see that there are instances where you may optionally decide to apply certain filtering conditions also. Okay? It's a just concise way of representing a new list. You ideally, there are instances or use cases where you have an existing list and you want to perform an operation on all the elements in the list and then derive or gain access to this modified list, right? So you can take advantage of so-called list comprehension. It's a shorter way of doing this. And once we start looking at things like Python pandas, for instance, you notice that these things will pop up over and over again. The syntax is simple, right? Open square bracket. You have a variable expression. I'm calling this var expression. And then you notice here that there's it's almost like you are using keywords that we introduced as being used when we are looping, is it? Like for here. Right? And in fact, in actual fact, what you're doing really is you are looping, but you're looping using a shorthand notation, if you will. Okay, so square bracket, open square bracket, close square bracket, and then within the open square brackets here, you have the var expression, and then you have like a shorthand notation for the for statement. So for each item in a given iterable object, if there's a condition applied, and then you return the expression. So in other words, and I think this will make sense when we look at examples really. In other words, what you would be doing here is you'd be saying you want to make a list of var underbar expression. And then for you to make this list, right, it's like for each item, right, in an existing iterable object, perform the operation. Okay, if there's a condition, only return things that that satisfy that condition. Okay, and you may be sitting there and you're asking, so, but why would we want to use them here? It turns out that they provide you with a very compact and faster way of performing certain operations that would require nested loops. Okay.
Doc, I have a question.
Yes.
The condition being referred to here, is it before or after the expression has been applied?
No, it's ooh, this is interesting. No, this is after the expression has been applied.
Okay, thanks.
Yeah, that's after. I think it's after. Yeah, it is after. We can check here, I guess. Yeah, we can check, I guess. Let's see if we can. We will activate our thing here. So let's say we want to return I'm just gonna have 1, 10, 20, 30, 40, 50. And what I want us to do is I want us to return, for starters here, I want us to return the of these numbers that are in the original list ideally. So in other words, what I want to do is I want us to return I don't know if my connection here, I'm tethering my phone, and I think it's hope we can still hear me.
Is it just me or is the line breaking?
I think the line is breaking.
Yes, I can hardly hear as well.
Connection. Sorry, everybody. I'm changing my connection here. I think my Liquid Telecom connection is is misbehaving. Just a minute. All right, there we go. Apologies for that. My liquid connection is misbehaving, and I was attempting to tell that using microphone, but my phone here is overheating because I've been online since 14 or something like that. But anyways, that's fine. So let's do some experiment. There's a question here where somebody's trying to find out if the expression that we have at end ideally is applied before or after, and I think my response was that this thing is applied after. It says confirm. It's always nice to do a confirmation, is it? So the experiment is going to be simple. We have a series of numbers in a list, Vanderbilt original. And by the way, I'm hoping that you can hear me now. Hello, can you hear me now?
Yes, the network has improved.
All right, thanks a lot. So we are saying that if we follow through with So sorry about that, everybody. Hopefully this will work now. My liquid telco, my liquid connection is just not working for me today. I don't know what's happening. It was working before. We had an exam. I had a meeting. I'm just coming from another class, and everything was working just fine. So sorry, I'm gonna have to ask again. Can you hear me now? Just fine. Can you see
Yes,
my
at this moment we can hear you.
Okay, thank you very much. Anyway, so we're trying to say we want to do a test, is it? So we have, we haven't really looked at the syntax in detail. So we have an original list like so. And what we want to do is we want to, this is probably a bad idea. Let's say we have numbers 1 through 5. And what we want to do is we ideally would want to take advantage of this comprehension and return the squares, right, of these numbers. I'm just going to say, var item raised to the 2, is it? Because we know that 2 raised to the 2 is going to give us 4, right? So I'm just getting the squares of these numbers. What I'm going to do is I'm going to say using this original list, what I want to do is I want to get the items raised to the 2. First, I want to apply the condition, right? And I'll say for var item in var original, right? I'm returning this. So in essence, I'm leveraging this comprehension, this example. Don't worry, we'll get through how this works to get the squares, right? It's a shorthand notation. In an ideal get this result, I'd have to look through my list. Ideally, if you think about it, we'll talk about an example just now. But using the condition here, we are saying that we would use the if
It's breaking again.
condition in such a way that let's say we want to get if item is less than, okay, is greater than 5 or something like that. If var item is greater than 5. Is breaking? Hold on to do the image. Hi again, everyone. I've exhausted all my options here. I'm not sure if my connection is still bad. Can you hear me just fine? And can you see my screen?
Yes, yes.
Yes.
Okay. Apologies for that. Sincere apologies for that. But so we're trying to do this simple experiment, and it appears. So I'll have to correct myself here. It appears what's happening here. If you notice, we have the original list. This is it, var underbar original, right? It has numbers 1 through to 5. And what I've done initially is I've just used list comprehension without the condition to get the result of applying the square to all of these numbers in here. So 1 squared, 2 squared, 3 squared, 4 squared, and 5 squared. All right. If I apply the square of all of these numbers, I'll get 1, 4, 9, 16, and 25. If I attempt to use the condition, remember our syntax is simple here. If followed by the condition, is it? If followed by the condition, and the condition I'd used initially was I want to just get var items that are greater than 5. I can say greater than 4 here. Anyway, in this particular case, I only have one entry here, which is 25. So the condition, to answer your question, the condition clearly that I'm adding here can be anything, but in this particular case, I'm applying the condition to the item, to the variable that I'm looping through here. If you notice, you know, so the condition, you have got to come up with your with your condition, and I don't know why I quickly said it. The condition is applied to the expression itself. You define the condition. You define the condition. What you could have done is you could have defined this condition in such a way that you have like a variable that holds some value. Say I want this value to be 4, for instance, and then as you're looping through, you're checking, is var item equal to the value that I've defined? So this condition typically is associated with the variable that you're using to loop through the list that you want to modify ideally. Okay, that's fine, ideally. So the question is, why use them? Well, they provide you with a very compact way and often faster way of iterating through a data structure in comparison to the traditional way of doing it, right? So we have an example in this particular case where traditionally, if we want to create a list that gives us the square of numbers 0 through 10, because we're using range here, we'll define it like so, is it? Yeah. So if we want to loop, so it's a task here. Simple task we are using here is the problem we are solving here is create a loop through numbers 0 to 9 and 0 through 9, get the squares of the numbers and add them to a list. Is it any list? So I'm saying for us to implement this traditionally, we would first of all have got to, if you look at the heuristic here, step 1, create an empty list. Step 2, loop through numbers 0 to 9. Step 3, for each number, get the square. Step 4, for each square of the number, add to empty list, to original list, right? So in essence, if you wanted to kind of like implement this very simple task here, right? What we are saying with the example we're using is you've got to figure out a way of looping through numbers 0 to 9. And if you want, really, you can say for var number in like so: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. For number in here, you're gonna say get the square, right? var number asterisk asterisk 2. This is how we get the square. In fact, we're saying if you're following through with the heuristic, first of all, we create an empty list, right? I'm going to call this var underbar results list is equal to empty. Remember, we are creating an empty list here because it's mutable. Because it's mutable, even if you create an empty list here, we can then start adding numbers here. So we're going to come here and we're going to say get the list results underbar list, and then append, right? Append the square of each number you're looping through. So in other words, what we're doing here is saying we're going to, when we're looping through this number, every time we're looping, the first time we're looping, var number is going to be equal to 0. We'll get this, we'll get the square of 0. 0 times 0 gives us 0. We append that 0 to this empty list. Right, so in loop number 1, this list is going to have something like this. It's going to have a 0. Okay, we loop again because we have got to loop 10 times, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We loop again. The next time we are looping, the number is going to be equal to 1. I may be talking to myself here, by the way. I'm going to pause. I think you can still hear me. It's going to be 1. When it's 1, we're going to come here. var underbar result dot list, it has 0 now. We say append. So when we append, when it's 0, it's going to be 1 squared is 1. So we comma 1. When we get to 2, it's going to be append 2 squared, which is 4. Okay, so in other words, what I'm saying is if we are to implement this heuristic, we would have to do something like this. Observe. First of all, define an empty list. Boom. Right? We can check var results. Empty. And then we're going to say we're going to loop through. We're going to loop through this list of numbers 0 through to 9. As we are looping, what we want to do is we want to append the square of each number that we're looping through, like so. And then when we check var underbar results list, we get the square of the numbers 0, 1, 4, 9, 16, 25, 36, 49, 64, 81. Right? So this is a traditional way of doing it. But we are saying, instead of doing this, what we can do is we can take advantage of this comprehension. And the syntax is simple, right? It's a comprehensive list here. We define a list, an empty list. Within that list, we've got to specify the expression we're going to perform on each of the numbers we are looping through. That expression for us is, we can kind of like already think about the variable we're going to use as we're looping through. So var underbar, I'll call this x. Now I say 4 underbar x, we're going to square this. What are we squaring? Every item that we are looping through in the original list, which would be this. Right, so for x in here, what do? Get the square, like so. Now, the example I have in the slides obviously is not, we're not manually defining a list like this, is it? We know that we're working with numbers in between, I want to say 0 to 9. So we can define these numbers 0 to 9 by doing what? By using the range built-in function. We just say range 9, range 10. Because range 10, if you remember our definition of, or rather, the lecture where we're discussing the range built-in function, we discovered that the way this works is, by default, it enables you to loop from 0 all the way up to the number used as a parameter minus 1. So what this returns really is what? This 0 to 9. And this makes sense, right? Imagine if the question was loop through numbers 0 to 100 to implement the same thing. You wouldn't want to manually type 0, 1, 2, 3, 4, 5, 6, all the way up to 100 here. It just doesn't make sense, right? What you'd want to do instead is you'd say, I want to define an empty list. Final list is empty. And then I'm going to loop for var x in range 100, so that I loop from 0 to 99. If I want to include 100, it will have to be 0 to, it would have to be 101, so that it's 0 to 100. So for x in range, what do I want to do? I want to return the square, right, of each number I'm looping through. When I get the square, I want to append it to this list. Dot append, like so. And then if I check var final list, this list is going to have the squares of numbers 0 through to 100. These are them, I guess, or something like that. Right? So the argument here is simple, right? Instead of you doing this, right? In some instances, by the way, we may have nested loops here. Instead of you doing this, what you can do is you can take advantage of list comprehension. So instead of 2 lines of code, you can have a single line of code. Is it get the value, square it, that's the expression, loop through what? I want to loop through range 101, right? So I'm saying for each item in this iterable object, I want to get the square, and then I'm going to in here, I'm going to get that. So the idea here is we're saying we want to do this in a very compact manner here. If this is making sense. Incidentally, by the way, what I could have done here is I could have said, instead of getting, if you want us to link it to what we've done, I could say import math, the same square thing. And then in here, I'll just say math dot, not square root. Oh, there's no square. I thought there was a square, but if we're getting the square root, I guess there's no math dot square. No, there's no square root. I thought it was square or something. Hope this is making sense. So again, to answer your question, the condition, it depends on how you define the condition, but clearly it's relative to the item you're using to loop through ideally. Now you might be sitting here and thinking, well, what if? So what if I'm using 2 lines of code, 3 actually in this case, right? For you to get this result, you first of all define an empty list, and then you loop through these numbers, right? So it's like 1, 2, 3 lines of code. Compare this with a more compact way of doing it, a single line of code. I don't know if that's a question. There's a hand up.
Yes, Doc. I have a question. So
Yes.
when I was trying to run that for loop, unfortunately, I had printed a lot of lists. So I think I realized that the print was within the for loop. So I'm wondering the logic. But if we print it outside the loop, the whole list is printed out nice. But the logic of it being inside the loop and then it's printing a number of lists.
Yeah, I know what you're doing. You're doing this. You're saying you are not using list comprehension. You're just using the loop, is it?
Yes.
Okay. So in case people are wondering what he's saying he's working through the example where we're implementing this heuristic, is it? This series of steps. First, create an empty list. Step 1, var I'll call this my list. Empty equals square brackets. If you want, by the way, you can say equals this. It will work, is it? It's the same thing. You can create an empty list in two main ways, right? You can use its notation, or you can use the built-in function list. I'll use the one that probably people are used to. So we define the list. And then what he's saying is he wants now to, what did you use? Range 101 or 10?
I used 10 range.
Okay, so if he's saying he's used 10, so he's using the traditional way of looping, right? And saying he wrote the code for var I in range 10 and what he did was he appended like this. I imagine dot append var underbar I squared, and then what he was doing, did you use the print or you just typed it in? You use the print? Hello? I don't know if you
Yes,
can
yes,
hear me.
yes,
I'm
I used
trying
the
to
print.
get what, and I don't know who asked that question.
I used the print.
Are you able to guide us what exactly again? Oh,
Yeah,
okay.
actually, what you are doing, and then down.
Can you hear me? Hello?
Yes, I can hear you, Doc.
Okay, thanks. So yeah, so what's happening here? Observe. If okay, and then this is it. This is what you got, right?
Yeah, yes.
So I can't figure out if there's something wrong with it. Okay, so what's happening if you did this is expected behavior, is it? It's a logical error. What is happening is, we can go through this one at a time. What is
Can't hear now.
I think network is unstable.
Yeah, colleagues, I do apologize. Today is just not my day. I have no idea what is happening. All my connections are failing me. This is my last ditch attempt here at. Can I again get confirmation on whether you can hear me?
We can
This is
hear
my
you,
final
sir.
backup. I don't know if you... Okay, thank you very much. All right. So there was a question, right? By the way, maybe because Friday is a holiday and thing here, I wanted to find out upfront here something to think about, food for thought, as I say. If you're okay with afternoon class Thursday, I'm available tomorrow, Wednesday and Thursday. I can create time at 13 hours. We can break up because of the disruptions here. We can break up a session so that we try and catch up. But you can let me know later on. The question was simple, right? It's like, why is it that he is getting? Why is it that when you write this chunk of code, these 3 lines of code here, he keeps on getting this? And it turns out that this is expected behavior. And ideally, what is happening here is what they call a logical error. Because what he wants is a situation where he just prints the final list. However, his chunk of code is returning all of these things. Now, you're able to better understand what's happening by looping through one at a time. Observe this code that we've defined here is going to do a couple of things 10 times, right? If you look at line number 21 here, we're saying for a variable var I in range 10, meaning that for the values range 10 simply means you're going to generate 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? So if you generate this, when you're looping, it's like...
Doc, isn't it just to 9?
Oh, sorry, yes, 9 without 10. Thank you very much. It's 10 minus 1. When you're looping, what is happening is you're saying in loop number 1, if you look at this definition, what do? You've defined this empty list, right? When you get into this loop, starting 0, I'm going to say in loop number 1, var underbar I is equal to 0. When var underbar I is equal to 0, you're going to do 2 things here. You are first of all going to append, right? You are appending to the list. In fact, in loop 1, where var underbar I is equal to 0, you are going to append to your list, which is previously empty. You are appending what? The value of var underbar I squared, so it's 0 squared. If you append it to the list, you're going to have 0. And then what you're doing when you append is you're saying print the list. So in other words, you're printing this list every time you're looping. So in loop number 1, you're going to print this, 0. When you loop the second time, in the second loop, var underbar I is going to be equal to 1, right? And then you are going to append. This is going to append to the now list which has 0. To 0, you append 1 squared, you're going to get 0, y. Because appending is just add this item at the end. And then you print it. So the next time you print it, you're going to print the list which has 2 items, 0, 1. In loop number 3, var underbar I is going to be equal to 2. You're going to get this 2, and then you're going to square it, append it to the existing list. You're going to have 0, 1, 4. And then you're going to say print it. So in other words, you're going to do this 10 times ideally, right? From 0 to 9. So you have 0, 1, 4, something like that. In other words, for you to get around this, what you're supposed to do is you're supposed to print this list after you loop. So it's as simple as doing this. So for you to get the correct behavior is you don't include this print statement as part of your for loop. All right, so if we run this, it's going to give us what you want, ideally. It's called a logical error, right? If we copy and paste this, this will work just fine. It's going to loop here. Var underbar my list dot append, and it's a var I on 2 squared, and then I'm going to print var underbar my list, and then I get this. So it's just the way that you're doing this. Anyhow, and the correct thing to do, by the way, is for you to get around this is you just define a function rather than just writing raw code like this, right? So what you could potentially do is you could say, I want to wrap all of this into kind of like into a function, ideally, right? df fx square list or something, and you say what this does is it takes in a list, right? When it takes in a list, what I want to do, in fact, it takes in a list which I want to modify. What I want to do is I want to loop, right, for var I. In fact, you could say, if you want to define this function here, you could say you want to, I don't know how you'd want to define this. Maybe you want to define this to take in as parameter the number of, in fact, we can define this without, but it wouldn't make sense if you don't define it without a parameter, now would it? We could say we want to define a value, right? Var x, and when we get that var x, it's going to enable us to create a new list which is going to have numbers squared from 0 all the way up to var x minus 1, right? So I could then do is could say I want to create this chunk of code here, copy paste it like so. Before you copy paste it, actually you say var underbar return of final list or something like that. Let's go to empty. And then you do the same things you are doing here. So var underbar final list dot append var underbar y squared like this. And then what you do is you say return var underbar final list. This is a more elegant way of defining this would be this, is it? So that you say, if I define this function like this, if I want to return a list that is going to have a list of numbers 0 through to n returned with their equivalent squared values, you just run this like so. Numbers 0 to 10, right? You have this. Numbers 0 to 101 or something like this. And I made a mistake again here. This is not supposed to be 10, it's supposed to be var underbar x, right? So that it's dynamic like that when you run it. Var underbar numbers 0 through to 9, numbers 0 through to 11, numbers 0 through to, I don't know, 100 or something like that, right? So it's more elegant way of doing this. Yeah, I don't know if it's making sense here. But so we are saying here, right, that instead of writing 3 lines of code, you can just do this in 1 line of code, or in 2 in this particular case because you have a separate print statement, right? But it can just be done in a single line of code. In other words, I've defined a function here like so. Instead of, and this is a nice way of doing this, instead of writing a function like this, what I can do is I can define a function square list 2 or something. It again takes in the variable x like this, is it? But what I can do is I can just say return a list comprehension, is it? I'm returning a list. In here, I'm returning a list, but how many lines of code do I have? 1, 2, 3, 4, 5. Using list comprehension, I can just say I want to get vi or vj squared, right, for var j in range var x. Is it? Is this syntactically correct? Observe, I have now 2, I can write it in the same way, right? Same kind of way. But instead of writing a function with 1, 2, 3, 4, 5 lines of code, and this can get complex actually, right? You can have things that are nested. You have just 2 lines of code, done. Least comprehension. I don't know if this is making sense here, okay? And then we've mentioned that you can add conditions, and the way you add conditions, if you notice our initial definition here, you have the expression for var item in the iterable object. You add the condition after the if keyword, and then you have a condition. The only thing to pay particular attention to is that this condition has got to evaluate to a Boolean expression. Okay, it has got to evaluate to a Boolean expression. Again, you notice here, if I think about this for a second, if I say, and we can use the same example, is it? Where we want to just get the square of even numbers, right? How do we do this? This returns the square given numbers 0 to x, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, or 0 through to 99 or something. It just returns the squares of those numbers, right? But what if I just want to return the squares of even numbers? Well, I can redefine this, is it, using the traditional approach. I'll just call this list even. I can redefine this. I'm still going to create an empty list. And then I'm going to loop through all the numbers. But as I'm looping, I'm going to check if the number is even. How do I check if the number is even? Well, there's if you remember the modulo operator, is it? If a number is even, like 4, if you get 4 modulo 2, it will give you 0, right? It's a nice way of checking if the number is even. So I'll just say, if this number that I'm looping through here, when divided by 2, here, get the remainder, modulo 2. If this gives me 0, then what I want to do is, this is when I want to append. I only want to append if the number I'm looping through when divided by 2 gives me 0. Then I append and get the square. Otherwise, I won't. Right? If I run this now, var list even, and I essentially feed it any number. Let's say I want to loop from 0 to 9. What this thing is going to do is it's just going to return the squares of 0, 2, 4, 6, 8, right? 0, 2, 4, 6, 8. If I want to get the even squares from 0 to 100, it will return this. Now, you notice here, the point I'm trying to put across is, using the traditional approach, I have 1, 2, 3, 4, 5, 6 lines of code. But if I want to use this comprehension, I can come up with a definition of this, is it? I'll call this 2, even 2. And just say return a list comprehension of the square of this number j, right? For var j in range var x, and then I have the if condition. If var x divided by, or modulo, var x modulo 2 is equal to 0. Right? Again, I have 1, 2 lines of code, and I can check if this thing works, which it should. Right? So fxn, the initial even, numbers 0 through to 20, I guess, returns these squares. Squares of 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, is it? I think 18 squared 2, right? Again, if I use the second version, it will work. What did I do here? 20? No, there's a logical error here. If this, if oh, sorry. If you notice, this is another logical error, right? I'm applying the condition based on the parameter when it's supposed to be the thing I'm looping through here, which is var j, like so. Another logical error. Logical errors are quite common in programming, and the way you get around them is through testing. So again, I'll retest this. The initial traditional one, which has 6 lines of code, when fed 20 gives this. The second one, which has a 2 here, when fed 20 gives me the same one as well. You understand here, least comprehension, ideally. I don't know if this is making sense, but hopefully it is or something. Now, in the event that you are wanting to, wanting to implement nested loops, right? It turns out that you can again take advantage of least comprehension. So, for instance, assuming we wanted to loop, right? We wanted to loop through numbers 1, 2, 3. And as we are looping through numbers 1, 2, 3, we are essentially creating a tuple that's going to correspond to, for each number here, we're going to get a pair of these values in the nested loop. So we want to get 1, A, 1, B, and then we're looping through 2, A, 2, B, we're looping through 3, A, 3, B. If we wanted to accomplish this using the traditional approach, you notice that we have 2 nested for loops, which can be cumbersome, by the way. Yeah? So we're saying instead of doing this, we can take advantage of least comprehension here using this notation. Is it? In other words, you're saying you're going to, first of all, define this outer loop, right? Where you're looping through 1, 2, and 3. Every time you're looping through 1, 2, and 3, you have yet another least comprehension, a nested for loop. So in other words, it's more or less like you're using this same notation where you have 4 looping through this. Inside the body, you have another 4, right? 4 inside the body, you have another 4, ideally. If this is making sense. So if you want to check exactly how this kind of works here. What you are doing essentially is you're saying, in this example, you are saying you are going to, there we go, much better. The expression that you are interested in returning is this, var underbar x, comma, var underbar y, right? Because ultimately what you're interested in returning is this. The end goal is this. And you have essentially 2 iterable objects that you want to loop through. The first one, which is the outer one, has numbers 1, 2, 3. For each of these numbers, you want to process them in such a way that you get the pair of the number you're processing with each of the values in the outer loop. So in essence, you're saying every time you're looping through here, every time you're looping through here, 1, 2, 3, loop through this other list, which has, as we call these characters here, A and B, right? Or strings A and B. And when you loop through this, in fact, because we are interested in returning a final list, we'll have to again define our final list as well, which is empty. we're going to get the var final list dot append. We're going to append the value of what we are looping through in the outer, comma, the new thing we are looping through, ideally. That's what we're doing, right? So that when we get the final list, we're now going to get this. Now, what we are saying is instead of doing this, which is arguably cumbersome, we can take advantage of list comprehension. The same thing we're doing, only this time around we're looping through like two objects ideally. So you first of all define the outer loop. You start off with what you want as the end result. This is going to be in a list, is it? It's list comprehension. What we want as the end result is the outer, the variable when we are looping through the outer iterable object. We'll call this, we can call this anything, A, B, or something, it doesn't matter, right? Or V and V and U or something like that. So it's going to be var underbar V and var underbar U. And then we are saying then, we're going to first of all start processing the outer loop. When we are processing through the outer loop, we're going to be looping through the outer loop using this variable here, var underbar V, in this 1, 2, 3. But as we're doing this, we have another an inner for loop, right? Every time we are looping through this, what we want to do is we want to again loop through the inner iterable object. So for var underbar U in this list here, A and B. Right? So in essence, this will give you the same result. I don't know. Much more elegant way of doing this. I'm not sure if this is making sense. You know, when you are, I guess it's the thing about programming, not I guess, the thing about programming is there are usually various alternative ways of doing things, right? So if you have logic that requires you to loop, you have the choice of doing this or this. Nobody's going to force you. The detractors of list comprehensions will argue that this is difficult to read when compared to this, right? The proponents of this will say when you're writing multiple lines of code, right? It's better if you use this sort of approach because you're going to have fewer lines of code you're working with. If this is making sense, I don't know. If this is making sense here. Any thoughts?
I have a question, Doc.
Yes.
Regarding the data structure, I see with the output from the code that you displayed was a tuple. Is there, what determines that? Is it because we had put the expression in those brackets? And if we change those brackets to square brackets, do we automatically get a list as our output?
Precisely. So the reason why that is the case is because I've done this here. Remember when we're saying tuples, we said we define a tuple by doing what? One of the ways we create a tuple is open parenthesis, close parenthesis. Inside here we have numbers. So if I have 1, 2, this will be a tuple with two values, 1 and 2. If I say 1, A, this will be a tuple with two values, 1 and the integer value 1 and the string value A. So this is what determines it. Guess what? If I wanted, and thanks for asking, right? If I wanted, I could have said, I want to do this. I want to return this should work here because we have integers, right? I want to return a list that will comprise of key value pairs in a dictionary where this will be the key and this is the value. So all I'm doing here is I'm just changing its notation. It's an expression. Expression can be anything. you know, expression could be anything, could have been a Boolean value or something like that. And really what determines what you want is the logic in your program, like how you would want the program to behave ideally. In an ideal case, this would be part of a much larger kind of like program that you're creating, right? Like right now, it doesn't make any sense here, but perhaps in the grand scheme of things, this logic would be desirable or something like that. I don't know. Okay, hope this is making sense. Any other thoughts or questions about this? Okay, I just have another example here, and I'm using this because I'm using this because we're going to be flattening matrices, multi-dimensional matrices using NumPy. So I have, in this example here, I have a matrix. This. And I guess this would be a lot easier if it's defined. Can I do this? I want to showcase something here. Seeing as we're going to be working with NumPy here, I might as well do this here. I'll call this matrix NP is equal to np.array or something like that. And then what I'm going to do is I'm going to copy paste this. Right. This is a 3x3 matrix, right? And this is a 2-dimensional matrix. So I have this 2-dimensional matrix, and maybe I have some sort of use case, right, where I want to flatten all of these things here, like convert this into a 1D matrix, for instance. In other words, what I want is, you see, I don't know if this is going to make sense here, but I have this, and the goal is to get 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, I know what you're saying here. No, but it's going to be a lot easier here. I just need one loop or something like that, right? Which I guess, I mean, could do one loop here. But if we're not working with lists here, it probably wouldn't be able to to work, right? If these were not lists. What I'm trying to say here is, if you define this, right? We're defining this as var matrix. We have a matrix, 2-dimensional matrix, 2D matrix like this. And what you want is you want to flatten this, right? In essence, return something that's just going to have all of these things collapse into one. Well, the traditional approach here, if you're working with lists, it's a lot easier. We're going to say for var for and a variable var number x in var matrix. What I want to do is I just want to, and I think I can add. I think I can define first var new matrix or something is equal to this. Is it? And then I think this would work. And then I say var x in var underbar matrix, right? And then I'm just going to say var, because when we can add this, is equal to, or I'll just say is equal to var underbar new matrix plus what? var underbar x. And if I check the new matrix here, it's going to work just fine, right? But if we had used a different example, maybe this would make more sense. If we were using this is a horrible example here. If let's say we were using this, it's a bad example. I want to showcase how complex this can be. If we had these were tuples instead. Okay, I know what you're going to say. Well, but Lighton, we can do things in a sort of like different manner here. If I have this matrix and I want to accomplish this situation, like what I would have to do here is I would have to loop through these things in a certain smart ways. Like I can't collapse them by adding them, because I can add these because I know that if I have two lists, right, with values 1 and 2, and I just add 5 and 6, it's going to merge them into one. This works just fine, which is why my logic only requires one loop. But if I'm working with tuples, for instance, it's going to be slightly different, is it? I can't replicate this and just say for this in matrix 1, I want to var underbar, sorry about this. I'm going to get the new matrix like this. I can't say I'm going to loop through this and just add, right? I can't come here and say var vx in var underbar matrix 1, and I get the same logic here, where I'm just getting the new matrix. I'm getting this odd. I'm getting the new matrix, and then I'm saying get the new matrix, and then add what you're looping through. This is going to be tricky because tuples are not immutable, right? What I would have to do is, for this to work, is I'm going to say loop into this, and then loop into each tuple or each tuple, whatever I want to call it here. So I'm going to say for var z here in var underbar x. And then once I loop through this, because I will have access to these things, I can then do the appending, is it? I'm going to say I'm going to get the new matrix. This is the only way it would work. New matrix dot append var underbar z. So if I check the new matrix here, it's going to have what I want, right? So what we're saying is, for us to flatten this, we can take advantage of list comprehension. Just another example of flattening idea, if this is making sense. Okay, hope this is making sense here. Just a visual representation showcasing the flow, right? What is actually happening. You are looping through this iterable object. In our example, it's range. You apply the filter, the if condition, and then you derive the expression for those that satisfy the condition, and then you have the result, right, of each element when evaluated using the new expression. Is a flow, sequence of events. Just showcasing, this was list comprehension, but there is such a thing as dictionary comprehension. So you can use the same logic here, where you'd be looping through. So you notice here, you're looping through an iterable object that satisfies a given condition, but the only thing you're doing here is you're specifying the key value pair that you want to use. Right, so this is a syntax idea. An example, we are saying we are going to create we want to create a dictionary given a range of numbers. In this example, 0 through to 4. We want to create a new dictionary which is going to use the keys, the values that we are iterating through, and the value part is going to be the square of that number. Right? It's as simple as this. And you notice all we are doing is we are changing the comprehension part here. Instead of having a list, the reason it's called the dictionary comprehension here is you're using the braces here. So for each brace that you're going to want to return, what you do is get as value the variable that you're using to iterate through this iterable object, and then the value is going to be equal to the square, right? The expression in essence. And then you get back this. I don't know if this is making sense. So in other words, we are saying if we wanted to return, the goal in that example is given numbers. We have a range of numbers, right? 0, 1, 2, 3, 4. I think it's up to 5 or something, up to 4. So 0 through to 5. what we want is we want to have a situation where we have a dictionary that will have keys, integer values corresponding to these original numbers. And then the key, the value part, these are going to be the keys. The value parts are going to be the square of these numbers. So it will be 0, full colon 0, comma, 1, full colon 1, comma, 2, full colon 4, comma, 3, full colon 9, comma, 4, full colon 16. So it's like, how do we achieve this? How do we accomplish this? Well, maybe this will make sense if we start off with the traditional approach, right? The traditional approach is you're going to have to create yeah, you're going to have to create an empty dictionary, because dictionaries are mutable, if you remember, right? Final dict, I'll call this final dict. It's going to be empty. And then you're going to say, I want to loop through values from 0 to 4, so range 5. When I'm looping through these values, what I wish to do is I want to add, every time I'm looping, so I'm looping through 0, I want to add to this empty dictionary a new entry. So I'll get this dictionary like this and say, I want this to be equal to this. This is all you're doing, right? This is how you accomplish this in a traditional manner here. Is it? You define an empty dictionary and then you start looping through the numbers. As you are looping, you're creating a new entry for this dictionary like so, right? For this key, give it this value. So if I run this, I'm going to do this stepwise. If I run this like so, and I run this for loop here, it's going to give me a dictionary with the values I want. So if I check the modified dictionary, I have this 0011 24 39 416. But what we're saying is that you can use dictionary comprehension, is it? And how do you do this? Similar to this comprehension, we're using the squares here, like so. For dictionary comprehension, it's a dictionary, brace, and then for the expression part, you define the key. In this particular case, my key is going to be the thing that the variable I'm using to loop through. I'll call this P, can be anything. Full colon, the value is going to be P square, right? Like this. And I say for var underbar P in the iterable object, which is the range, right? 5. Do this. Do you understand this? So it's just a shorthand notation. You have to choose your poison, I guess, in this particular case, right? Some people, I know when I first of all got started with Python, I used to gravitate more towards the more traditional approach because it's a lot easier to understand, I guess, to understand what's going on with nested loops. But just to let you know that there are more elegant ways of doing this, okay? More comprehensive ways of doing this, I guess. Don't know. Okay, so the question then is, what about when we want to filter, right? Well, I mean, this is an example here. We have our list that we've been using with Alice, Bob, and Charlie. So this is a dictionary which has, I want to think that these are names of students or people with their corresponding ages, is it? Our keys are these strings corresponding to the names, and we can have names as keys, right? Because strings are immutable ideally. The values are the ages. So if we wanted to use list comprehension to return only like a dictionary of people who are, I guess, not minors or something, over the age 18 and over, what we would do is would take advantage of dictionary comprehension. But you notice here that what we are doing is we are including as a filter here, we're including as a filter the value part of the original dictionary. I don't know if you can see this. In other words, I'm going to copy this and paste it here so that people are able to kind of understand what is going on. Yeah. It's a very lengthy expression here. Observe, we are saying that the expression is going to be this, right? The expression is still going to be, it's going to be the same as what we had before. We want to return a dictionary that will have the name as a key and the age as a value, the final result. But we want to process this original dictionary in such a way that, I'm just going to go get original dictionary here. We want to process it in such a way that we need to check if this value part here is greater or equal to 18. So in other words, we just want to return Alice because she's 22 and Charlie because he's 19 ideally. We want to exclude Bob because he's 17. The way we do this here is that for us to loop inside, the way we do this is we need a smart way of gaining access to the value part. And how do we gain access to the value part? Well, we can use the dictionary method items, is it? Because if you remember, we said that what items does is it returns an iterable object, right? Items. It returns an iterable object which will get your dictionary, the dictionary entries, and return a tuple or a tuple that has the key and the value in a separate tuple. Dictionary element 1, dictionary element 2, dictionary element number 3. Using this, what we can do then is we can gain access to this component here. Yes. And how do we do this? We said, if you remember, we said that if we use the item part here, we can iterate through this in such a way that we have something like this. For var x, comma var y in here. You remember this? Var x, var y. I don't know if you remember this. Because this thing returns separate items, right? Separate in as a tuple, but with a tuple with two elements ideally, the key and the value. We can look through each of these pairs here at the same time, x and y. So in effect, this is what we're doing with our dictionary comprehension in this particular case. We're saying in the 4 part here, the end result we want is the same, right? Name as a key, age as a value. But when we are looping, we're not just going to loop using one value, but we loop through two values, two variables here. One representing the key, the other one representing the value part. The only way we can loop in such a way that we have the key, and the values by using the items method, the dictionary object. And then in the condition part, we're using this part here to check if the age is greater or equal to 18. I don't know if this is making sense. If you're thinking of how you would implement this using the traditional approach, you would, so var adults here, adults is this. You would say for, you first of all define, using an actual for loop, right? Not using dictionary comprehension. You define first of all, new dictionary, empty, right? And then you're going to loop through the original dictionary, which is this. So you say for var underbar, I'll call this C, comma var underbar D, right? In this dot items. And what I'm going to do here is I'm going to say, when I'm looping through the dictionary items, first I process Alice, then Bob, then Charlie, right? The Alice part is represented by this first variable var underbar C. The age 22 is represented by var underbar D. When I'm processing Bob, Bob will be represented by var underbar C, 17 var underbar D. Charlie, var underbar C, 19 var underbar D. And then in here, I'll have to check first, is it? If var underbar d is greater or equal to 18. What I want to do is I want to, in the new dictionary, I want to use the key of the thing that satisfies this condition and then assign it the value of the thing that, that satisfies this condition. So I'd process it like this, and then eventually I would have the same thing here, like this, right? If this makes sense. I don't know, you choose your poison, right? It's like this is the same as what we have here. It's the same as this. You understand? This single line of code here is exactly the same as this. If this is making sense, I don't know if this is making sense here. You know, and then, I mean, I just have an example here where I'm creating, you know, a dictionary from two lists, and we can take advantage of the zip built-in function, is it? I don't know if you remember here, if you have two list entries which have a match in terms of indices. So in this particular case, index 0 for var underbar name matches index 0 for var underbar age. We can use zip, is it? When we use zip, it's more or less like we are combining, or as we are looping through this zip entry here, we're going to be looping through, when we're looping through Alice, we're looping through 22. When we're looping through Bob, we're looping through 17. Charlie, 19, ideally. I just included these things to try and link to our discussion of these things here. Functions. I don't know if you remember the zip, right? We discussed what zip does. I do apologize. It appears I was talking to myself. I don't know what's happening here. I have no idea for how long I was talking to myself here.
So you're still talking to yourself.
Colleagues, it looks like today is just not my day. I was talking to myself again. I don't know for how long I was talking to myself. Sorry about that. I just noticed that I lost connection. How long was I offline for?
About a minute or two.
Yeah. Well, I was, I do apologize. Today is one of those horrible, horrible days here. Sorry about that. I was, I was essentially trying to, I was essentially trying to talk about the fact that a nice way of thinking about, you know, kind of like dictionaries here is relative to how you would accomplish the same thing using your traditional approach, right? Using your normal for loop or nested for loops, ideally. And really, as Elia stated, the choice is up to you, right? When you're writing a computer program, if you need to include logic or something like this, you would have the option of doing this, ideally. And nobody's going to prescribe this for you. You get to decide to do that yourself as a program. Okay. I don't know if any thoughts or questions about dictionaries or something. Dictionary comprehension, rather. If not, today I had planned that once we are done with this part, we were supposed to start our discussion of the NumPy library, ideally, but because of the mishap that keeps on happening, I think once we're done with Lambda function, we can just I'll leave it up to you to decide on when you'd want us to have a session to make up for we've lost quite a bit of time here, the technical glitches, and we started late as well. But anyways, so next up is our discussion of so-called Lambda functions. A Lambda function is nothing more than an anonymous function. So there are instances, right, when oh yes, there's a question.
Yes, Doc, sorry to drag you back.
No.
When looping in dictionary, let's suppose you just want to loop through the keys alone.
Okay.
Yeah, how do you go about that?
Nice sort of thing about this. I want to copy this and for var key in. Okay, I'm going to start this by saying var underbar origin. You remember dot keys, yeah? Remember this? There's a dot keys function. So what you can do is you say for var underbar key in var underbar origin dot keys, right? Print the key. So I'm looking through the keys. Is this making sense?
Yes, that clarifies.
Yeah. Anyhow, I guess the other way you can do this is, although it doesn't make any sense here, but you could also say var x or var k for key, var v for value, in var underbar origin dot items. Is it like this? And then what you do is, in as much as you're looping through both the keys and the values, you just want to print the var underbar key. Works as well. So it's just if you want to figure this out, you just want to remember that there are these methods, right, associated with the dictionary object that you can play around with. Okay. The same goes for if I want to loop through the values, is it? It's var underbar, call this values, value, var underbar values, like this. Print the value, right? Get the values or something like that. I don't know. Or the other approach would be, well, I have the dictionary var underbar origin, and I want to get the values. I can loop through the keys, right? Using key. But when I'm printing, I want to print what? The original dictionary by feeding it the key. Because I know that this notation gives me the key. So this would be the same, if you notice. And again, thanks for asking, because this kind of underscores the point I was trying to put across. So in programming, there's usually multiple ways of accomplishing the same thing. This is the same as this. It does the same exact thing, but the implementation is different, right? Is it? But they do the same thing. If this is making sense, don't know. Okay, hope this is
Thank you so much.
helping things. All right, so I was just saying there are instances where you may want to define a function, okay, and you're defining this function in such a way that it doesn't have a name. It's called an anonymous function, and there are a number of instances where you want to do that, right? You'll see instances when, or showcase examples when you'd want to do that. It's tied to the discussion we are having with list comprehensions here. Okay. So the syntax really is you use the lambda keyword. Again, if I do the import keyword and do keyword dot KW list here, you notice that lambda is a reserved word, right? It's a Python keyword. So there you go. So the way you define an anonymous function is you use the lambda keyword followed by arguments, and you see an example here, followed by full colon and then the expression, like the body, right? So what this will do is it will return the value of the expression, ideally this. Now the question to ask is, when would you want to define an anonymous function? Well, there are instances where you just want like a simple function for a short period of time, right? For instance, you are using what? List comprehension or dictionary comprehension, and the thing you want to do is you want to maybe the expression that you want to return here has got to be some function or something like that. You can use the lambda function. Look at some example just now. So there's an example here, right? We have the normal way of creating a function. We are saying we use the df keyword followed by the name of the function, and then we have open parenthesis, one parameter under by x, close parenthesis, and what this function does is it returns the square of the argument provided to the function, right? The lambda equivalent could be defined as follows. There's a variable that's going to hold the function itself. Yeah. So I have lambda var under by x, the body which is var under by x squared ideally. And every time we evoke this thing here with an argument, for instance 5, we get the same result we get when we evoke fxn under by square ideally. Right? So in other words, what we are saying is that what you have here, your normal function, is exactly the same as its lambda equivalent, which is this, a one-liner. Okay, so if I run this, type fxn square function, and I run this, the end result when I feed them argument is essentially going to be the same, fxn square lambda. Oops, sorry about that. Right? It's also a function. You understand? Okay. And I'm just using this here to hold the result of this ideally. So both this and this and these are functions ideally, except this is an anonymous function. Right? I just have an example here where I'm using lambda with map function, right? And in essence, if you remember our discussion of map function, we said that what it does is it allows you to apply to apply something, right, to each element of the list. Is it? I want to double back here to remind us of what we're discussing, just briefly, in case people have forgotten. I think we discussed this. Oh my goodness. Did we not? We must have discussed this. We must have discussed this, right? I'm going to double back here. I think I remember we discussed this. If we didn't, then I don't know what I was. I think during our discussion of functions or something, we may have discussed this briefly. Maybe not. There we go. Here, right? I said that the map function is a built-in function, right? There's map here. Is it? It's here. It's a built-in function. But the way it works here is it takes in a function and an iterable object, ideally, right? And what it does is it uses this function to apply. It uses this function is applied to everything in here. Okay. So what we are saying is the normal way of doing this, and I'll show you an example, is if you wanted to use a map function somehow, when I used it last time, you say you first of all define a function, yeah? And then after defining the function, is a lambda with map here. Here, you have a list here, right? And what I want to do is, I am interested in getting the square of all of these numbers, right? Now, if I want to get the square of all of these numbers, if you think about it, right? I'll come back here. If I was to give you a scenario to say, using input this, give me the squares of, give me a result of getting the squares of all of these numbers. And I know what you're thinking. Well, I'm going to use list comprehension Lighton, right? Okay, that's another option. Or I can do this the normal way where I start looping, is it? For, I define first of all the empty list, the final list, right? And then it's an empty list, so var final, like this, is equal to empty. And then I say for var I in var numbers. What I'm going to do is I'm going to say var final. This is the normal way, append, and then I get the square or something like that. This is too tedious, right? And then I can say, well, I can also use maybe as an alternative list comprehension. Well, you can take advantage of these built-in functions that act on data structures that we've discussed, right? Combined with a predefined function, ideally. Yeah. So in essence, using an anonymous function, what I can do is I can say I want to create the square of these numbers here. What I can do is I can use the map function, because I know map applies, given a function, it will apply everything in a given list. I have the list, which is this. All I need is a function to get the squares of these numbers. Now, how do I define this function? Well, the one approach I have is I can define a function here. Squared. It gets in a number, x. And then it returns squared, right? So I define this. And then after I define this, I say, I'm going to run map. I define this, and then I get my list, var numbers. And then I'm going to use the map built-in function, which takes in a function, comma, the list. What I'm going to get back is numbers. What I'm going to get back is an iterable object, which I can then cast into a list like this. Is it? The squares. But you see, the problem with this is too cumbersome. I have to first of all define this function, right? After I define it, I then evoke it as part of map. And the argument here would be, this is only needed at this point. I'm not using it anywhere else. If I'm not using it anywhere else, I might as well define it as an anonymous function, right? And how am I defining it as an anonymous function? Where I have this function that I defined before. I can add the anonymous function. So I still have the same thing, map. Right? But what do? I have lambda, right? After I have lambda, I have the expression here, right? In other words, the parameter that I've got to use for this, full colon followed by the body, which is just var x squared, like this. So this would be the same as well. In other words, we are doing the same exact thing we did before by defining this function here, except this is wasteful, right? We're wasting our time because the only place where we are using this function is in this map. So if this is the only place we're using it, we might as well just define an anonymous function. But again, like I said, programming is all about alternatives, right? You can decide to say, even if the function I'm defining is only going to be used once, I would much rather define it the traditional way, which is this. It's okay as well, right? But anyway, thought I'll showcase an example of using lambda using map. But you can do the same thing with filter, right? Again, if you remember filter, right? The way filter works is, I don't know if you remember this. I'm going to double back. You have a filtering function, is it? Double back briefly. To remind people what we did. It was under functions, I remember. Where are you? It should be coming to here, right? The way filter works is it takes in two parameters, is it? Or two arguments. A function that you use to filter and an iterable object. So the idea here is the function has got to work in such a way that when fed an argument as one of the elements in this iterable object, it will check if it satisfies that condition. Again, the traditional way to do this is, let's say I wanted to just return, and I think this is what the example does here. I'm going to go back here. We want to return a modified version of let's go back to filter here. We want to return the same thing we returned here, the squares, but in this particular case, we just want the squares of, I think these are even numbers ideally. It's like, how do we define this? Well, the normal way of doing this is, first of all, we're going to define a function. We can define a function here, even, right? Even takes in a variable x, and it just returns true or false. So for this, it returns true if this number var under x is true. I mean, is even. So how do we do this? We check first if var under x modulo operator 2. If we divide this by 2 and it gives us 0, then return true. If you want, you can even have an else. Return false. Right? So that if I have the I don't know if it's the original here. What list did I use here? Numbers. If I have my numbers here, var under numbers. Numbers, please. I can use the filter built-in function, which takes in a function that returns true or false, right? When applied to the argument. So I want to check which of these numbers here is even, right? Sorry about that. I need to cast this into a list. Which of these numbers are even? 2 and 4, right? So I'm applying this condition here. Now, the argument here is that this is just too much because I'm only using it once. What I can do then is I can define an anonymous function, is it? Using lambda, right? Using lambda. So in this particular case, I'm just going to say, it's just a condition, it can be one here. I'm just going to say filter, same syntax, right? The filter is going to act on numbers, but instead of defining the function with def and the body and stuff, I'm going to use lambda, right? Lambda followed by the input, the parameter is just 1. I'll call this even, I can call it var x because it's, I mean, the scope is just within here, is it? And then the body, is it? if var underbar x divided by 2 is equal to 0, ideally. So this will work as well. Shorthand notation. Same thing. You understand? It's just that it's a different way of writing a function. It's an anonymous function. Instead of defining a function in such a way that it has a name, it has no name, which is why it's anonymous, right? Lambda function. And then this example just uses lambda to sort, is it? I have a dictionary with, I have a list with tuples corresponding to key value pairs for names and corresponding ages, I guess, of students or something. And what I'm interested in doing here is I want to sort, I want to sort these entries in such a way that they're in ascending order of age. These are not sorted in age, is it? 22, 20, 25, right? So I can use sorted, is it? And the way sorted works, again, is it will take in, you just have to look at the definition of sorted, I guess. It takes in an iterable object. Sorted is built-in function. I do help here. It takes in what? An iterable object, right? And a custom key here. By default, it's none. A custom key function here specifies the sort order ideally. Yeah, by default, it's none, meaning that it just uses natural ordering. For instance, if I have a list of integers, just going to order them in ascending order or something like that, right? In other words, what I'm saying here is if I have a list 1, 5, -10, and I use sorted, the way sorted works is if you look at the definition here, is by default this key-weighted parameter called key here is none, but you can feed it a function, okay? And this is what we're doing here. We have our dictionary, and what we want to do is we are defining an anonymous function that takes in it takes in a variable s, and then it returns. This is weird here. Let me just check here. This is yeah, this is very strange here. Let me just check how the custom function works here. I'm a bit confused here as to what is happening with key here, is it? Customize sort order and the reverse flag can be set to, I have no idea what's happening with the one here. I don't know if this is actually, so I'm going to copy paste this and then let's see the behavior here, I guess. So we have a dictionary Vanderbilt students. And then what we want to do here is we want to return sorted variation of this, but we're using a, let's see here, I have no idea how this is working here. Given a function value s, this is a bit weird here. I'm not really sure what how this lambda function is actually working. Maybe we can redefine this, right? Var x var s var s. S. Yeah, no, but the thing here is it still returns. Right. Okay. So what this is confusing. What what this is doing is we are. Sorry about that. I guess I'm tired here. What we are doing is because we're trying to tell sorted that the key we want to use to sort by is going to be the value. So we are actually getting 0, 1. So we want to sort by this this idea. If this is making sense. There we go. I think I'm just tired. Incidentally, what you could have easily done here, what you can also do here is you could even have something like this. This returns Bob, Alice, and Charlie. We can have reverse is equal to true, so that we reverse, not reverse, so that we start with Charlie ideally. So what this is doing is we're saying we're defining a lambda function that's going to sort. The key that we're going to use here is the second value in the tuple here, which is the age, is it? Okay. If that makes sense. I don't know if it's making sense. Anyhow, I guess we are all tired here. Again, just a visual representation showcasing how this would work. Nothing fancy here. And then I have like a hypothetical real-world example, right? You have a list of customer orders, and each order is a tuple or a tuple like this. You have order ID, customer name, and the amount, is it? What you want to do is you want to get the total revenue, and also find the average order value and get a sorted list of orders by amount or something, and also get a set of unique customer names. And what you begin to notice is that you can play around with this tuple. And I can leave you with this to just try and see if you can figure things out here. It's a hypothetical real-world scenario that kind of illustrates how you can use lambda functions, is it? Right, to address this or to solve this problem ideally. You can do it the traditional way, by the way. That's not a problem. But we are saying, can we answer these 4 questions here? Can we get this information using lambda functions? So we define our list of orders as tuples, right? ID, name, amount. ID, name, amount. So we have 4 orders from 4 different people here. Or 4 orders from 3 different people. Alice has 2 orders ideally. For us to get the total revenue, we are saying we can take advantage of the sum built-in function ideally and just do list comprehension, right? Using this. So we're getting the amounts in the orders, right? We want to get this, right? So get the amount when you're looping through these different items here in each order. Sum up the amount. And the key thing here is, by the way, in case this is confusing, we're unpacking here, is it, if you remember. So we get the orders. Let's do this together so that we are all on the same page, I guess. We define our order like this, var orders. The first part is we want to get the total revenue, is it? For us to get the total revenue, we want to sum up this, and that. Right? So what can we do? We are saying here that we can take advantage of the sum built-in function. Right? And if you remember, we said the sum built-in function. I don't know how much of this you remember. By the way, I can't. I thought I was talking to myself here. What the sum built-in function does really is it takes in an iterable object here, right, and just returns the sum. Yeah. So how do we define an iterable object for our order? This. Well, we are saying we can loop through here because these are tuples, is it? Because these are tuples, we can unpack this for order, right? I'll call this ID, and then var name, and then var price or amount in here. If I just print the var A here, it will print the amounts, right? This is why we're using this shorthand notation here to say we're using kind of like list comprehension here, right? var amount for underbar. We don't care what this is, can be anything here. In case it's confusing here, this can be defined like so. We're using list comprehension to say the amount, I'll call this v var name, and then var ID or something like that. Doesn't matter, right? We are still looping here. I want to sum this up, right? I'll get 800. This plus this plus this plus this. That underscore is just a way of representing these other values in our tuple, because our order has one, for each order we have 3 elements, right? ID, name, amount. ID, name, amount. But we're just interested in summing the amounts. Okay, so we can do that. And then the average order, pretty straightforward here. What do? We can use the total revenue, is it? Right? It's getting the average, notice here, find the average order value. Get the sum divided by the number of orders. What is the number of orders? The number of orders is just going to be len built-in function for var order, right? When we use len on an iterable object, it counts the number of elements. So we have 4 orders here, and we know the sum, which is this, the total revenue. What is the average? Average is equal to the total divided by number, which is var len. I'm just gonna have to do something like this. 200, quite. I guess, I don't know. Right, this other question is saying get a sorted list of orders by amount, right? And again, what we can do is we can just use the lambda function to change how we want to sort. How do we want to sort? We want to sort by amount. Okay, so how do we sort by amount? We define an anonymous function that's going to take into it's going to take in as input the tuple, right? And then sort by the second item, 0, 1, 2. 0, 1, 2. This is why we have this. And it's going to be sorted. Incidentally, this by default is going to be sorted by what? In ascending order, right? So if we come here and paste this here, this is going to be sorted in ascending order of the order amounts, is it? If we check, how am I doing this? I remove the variable here. If we just run sorted here, what we're going to get is we're going to get this order sorted in ascending order of the amounts, 100, 150, 250, 300. If the question flipped and we wanted this sorted in such a way that it's in reverse order, we use reverse is equal to true, right? So that we start with the highest, 300, 250, 150, 100, ideally. And then the way we would solve the last part here, where we are interested in getting a set of unique customer names, well, I guess you can use set, is it? A set has a unique property in that it what? It's going to return unique entries. You never have duplicates, right? So what we do is we define a set using list comprehension as we are looping through the orders. So we loop through the orders. In other words, we have our orders, var orders, right? And then what we do is we are going to loop through the orders here. As list comprehension, but what we're doing is we're saying var I in orders. Oops. You are printing what? For each tuple, get the name is at what? It's at position 1, 0, 1, 2. So we want to get the unique names here. we're using this comprehension, but the way we are using this is we are just looping through all the names and then defining a set, because we know that a set is always going to have unique names. This is why we're doing this here. Var order get names for var order in var orders. We're just going to return this. And if you wanted to return this as a list, you could just cast it, is it? Say a list like this. If this makes sense. Okay, I think this is it. This is just a mistake here, duplication, but I'm not sure if this was, sorry for the technical glitches that we had today. Today was horrible, but I hope this was insightful, and hopefully we've picked up on quite a number of things here. You will see us using some of these things soon. I think when we are using NumPy, for instance, we will do this. Are there any questions? Okay, I think people are tired with the.
Sir, will you post this lecture on Google Classroom?
Yes. The recording or something?
Yes.
Yeah, I'll post the recording and all the changes. I think there could be some changes. I don't think there are changes. There could be some changes, but I'll post it, yes.
Okay.
All right. Well, colleagues, thank you very much. We see now we had a number of technical glitches, and then we started 30 minutes late or something like that, slightly more. I wanted to ask if you can liaise amongst yourselves for us to just have a lunch hour slot and catch up or something. I'm trying to avoid organizing classes during Easter or something like that. But you see now, we even have Easter Monday or something like that. But I want to say something here. Today is the 30th, and I'm proposing that we have a test in 3 weeks' time on the 20th. And the test is going to cover, there's the 30th. It's going to cover stuff that we've done in this module. Done quite a bit here, right? In fact, we've pretty much exhausted our discussion of like a gentle introduction to Python. You know, what we're covering next are things associated to specific libraries, ideally. So I wanted to, I'm just saying that we're going to have a test, in-person test. And I want to suggest that we have this during the week of the study break or something like that, which is the 20th. Okay. As you give it to, yes, there's a question there.
So are we going to have a tutorial over this just to have a feel of what kind of questions or how the test is going to be?
Well, so I've provided the labs that I've provided. I don't know if you've had a chance to look at the things where I was showcasing, and I was responding to a question that was shared. So
Yeah.
this ideally is what you should be expecting. So the things that I've tagged as examples, and labs actually not examples, should give you an idea of of what to expect. And because this is one of those very unusual kind of like postgraduate courses where you actually have like a dedicated programming course, right? Most of these, it's quite normal really, because the number of people that perhaps are enrolling into this program have little programming experience really, which is why we have a dedicated programming course. But this is typical of like a typical postgraduate course, right, where the focus is just on programming. So no dedicated tutorial per se, but what I've been doing is I can share more example code to help you understand. The questions are going to be scenario based. I can expand on this really and include other questions that are going to mimic what you should expect in the exam. if that would be helpful or something.
So I have a question on how the test would be administered. Would we be writing code on computers or on paper?
No, well, it's going to be a little bit of on paper, and it's not like going to be complex code. So in some instances, just filling in the blanks, or given a scenario, write a function that does this, a simple function. What is the output of this? How does this change, and all those things.
Noted.
So,
Thanks.
yeah, so it's not using a computer. It's we are trying to mimic what's going to happen in the exam, is it? Where we'll be there writing code on paper or something. I guess, I don't know. And it's not going to be purely code. I guess it could be like questions that are phrased in a certain manner, right? All right. Unless there are any questions, I think we can leave it at that. This is 2038. I'll be waiting for feedback. I would want for us to catch up on the lost 1 hour. It's just the line. That's it. Thank you, everybody, and yeah, thank you very much, and good night. Bye.
Good night.